How's it going, you guys? In this video, we're going to be getting into more of graphing quadratics. I know we got into a little bit last time. We're going to talk even more about it this time. So given standard form, don't forget that standard form is ax squared plus bx plus c. All right, the vertex is negative b over 2a for the x part, comma f of negative b over 2a. Don't get freaked out by this. This is just saying if you put in negative b over 2a as your x value, that your y value will come out as your y value of the vertex. I'll show you how it works. It's really easy. X-intercepts. Know that they are also called zeros, roots, or solutions, but it's just where our graph is crossing our x-axis. So here would be an x-intercept, and there would be an x-intercept. Both of those circled spots right there. They are the x-intercepts, zeros, solutions, and roots. That's the four things that they could be called. But we use all of our intercepts, the x-intercepts and the y-intercepts, to help us graph our quadratic so much easier. If we only have one solution to a quadratic, sometimes it is called a double root. It will bounce at the x-intercept. We'll get to one, yes, we'll get to one in this video, that you will see what happens when we have like a bounce or a double root. That's just called the multiplicity being higher than 1. I don't know if Apex talks to you about that or not. I don't think they do, because that's kind of a pre-cal concept when you get to multiplicity of graphs. All right, but moving forward. So we have, we're only doing 3 examples, so it should be a pretty short video. Determine the x-intercepts of the function and find the vertex. Then graph, state the domain and range. So to find the vertex, you could complete the square if you wanted to and put it in vertex form. There's nothing wrong with that. But for the vertex 2, we also know that negative b over 2a will give us the x value of the vertex. Notice I left the y value blank because once we figure out the x value, we can plug in the x value to our equation to figure out the y value. So b is this negative 4, so I have negative 4 over 2 times a, which is 1. Still leaving the y part blank. So this will be negative 4, which is positive 4, divided by 2 times 1, so divided by 2, which would just give us 2. So now once I know my x value, I'm going to go back in and plug it into my function to figure out what the y value is of my vertex. So I have 4 minus 8, which is negative 4, minus 12 is negative 16. So I have 2, negative 16, so I'm all the way down there somewhere. There we go. All the way down there somewhere. I went to 2, negative 16 to get to the vertex. And I know this thing's going to be opening up. So now the next part that's going to be helpful is finding our actual x-intercepts. So to find the x-intercepts, I like to graph this thing to actually help me find them. I think this was actually the last one that we did in the last video. So I have x minus 6 and x plus 2, which would mean I have an x-intercept of 6 and negative 2. I like to list my x-intercepts as ordered pairs. So remember, that's just when the y value is 0 is when I have an x-intercept. So I have an x-intercept at 6. I have another x-intercept at negative 2. And I have my vertex. Now using my vertex, I can graph my quadratic best I can. There would be my quadratic. And also notice, the vertex happens exactly in the middle of the 2 x-intercepts. So from negative 2 to 6, I can count 1, 2, 3, 4, 5, 6, 7, 8 units. So 1, 2, 3, 4, and 1, 2, 3, 4 units away from either one is where my vertex is located. So if you can find the x-intercepts, the vertex is always going to be in the middle of the x-intercepts. And then if you want to find the y value, you can also plug the y value back into the equation, just like we did before. All right, so the last part of this, we graphed, so we graphed. Now we're going to state the domain and range. So for the domain, this thing is going left and right forever and ever. So we have from negative infinity to infinity. And for the range, the lowest value that I have a minimum right here at negative 16. That is included in my graph, so I'm going from negative 16 all the way up forever to infinity. All right, moving on. So here, for our, let's go ahead and try to find the x-intercepts first, and I'll show you how you can use that to find your vertex. So if I try to factor this, this would be x minus 3, x plus 1. So I would have an x-intercept at 3 and an x-intercept at negative 1. So I have an x-intercept at 3 and negative 1. So for my vertex, if 3 and -1 are 4 units away, my vertex should be when x is 1. So for the vertex, since it's right in the middle, I know my x value is 1. So for the y value, I can put in 1 for the x's. So 1 squared is 1, minus 2 times 1, so minus 2. So 1 minus 2 is -1, minus 3 is -4. So I have a vertex at positive 1, -4. There would be our graph. So pretty. Oh my gosh. All right, so there's our graph. And then to determine the domain and range, I'll do it up here real quick. So the domain is always still going left and right forever and ever for any parabolas with an x squared. So now for the range, the lowest y value is -4. It's a minimum. So I'm going from -4 up forever to infinity. All right. Oh, and I didn't list the x-intercepts as ordered pairs, so it'd be 3, 0 and -1, 0 for the x-intercepts. Cool. All right, last one. Amazing. We're going to finish in under 10 minutes. So again, try to factor this if you can. So x minus 4 and x minus 4. So that means we have x minus 4 squared. So now notice, I have the same factor, so it's only going to give me one solution. And if I notice on that one solution, it has an exponent of 2. That's what I was talking about earlier when I said the multiplicity. That means the multiplicity of this 0 is 2. You only need to know that. This is called like a double root though, which is obviously the same thing as the multiplicity. But what that means is at 4, when x equals 4, the graph will kind of bounce off of that point. It's not going to actually cross through the x-axis. So again, since I have an x squared, it's going to open up, and it's going to open up from that x-intercept of 4. It can only have one x-intercept, so it's kind of touching the x-axis right there, and then it's bouncing back away. So that's why I call it a bounce. So it's kind of going all the way up to it. As soon as it hits it, it looks like it hits a wall, and it bounces back the other direction. So that's if you only come up with one x-intercept. It has to be bouncing for a quadratic. So that makes the vertex really easy as well, because since there's only one x-intercept, I can physically see the vertex. The vertex would be the same as the x-intercept, which would be 4, 0. So this is the vertex. This is also the x-intercept in this case. Then for our domain and range, the domain is still going left and right forever, so -infinity to infinity. And then the range, the lowest y value, it's still a minimum, is 0 to going up forever, so 0 to infinity. All right, that's all I got for you guys. So please, please, please make sure you guys get some good practice on this. Let me know what questions I can answer for you. I'll see y'all soon.